teach you, by the way.
Go. And these animations are all in lovely 4K, so you should go and watch them. We'll include them in links in the follow-up email. How long did you all work on this, Greg?
Sorry, the connectome or the videos?
The connectome. I know you put a lot of work on this video too.
Sorry, which was
how about
the
how about the connectome? How long did you spend working on annotations?
So I guess we started proofreading in kind of a bit before lockdown, right? So I guess we were one of the first groups to do some serious work. And the annotations, we've been working on them, I guess, probably 18 months, but especially heavily since last October when we kind of finished, finished up the central brain with Sven and co, and then we stopped proofreading and moved on to doing annotations sort of 100%.
Oh, and I see Sven is here. Hi, Sven.
Yeah.
All right. And then one more little piece of eye candy before I hop into a Codex demo. This is another video from Greg's lab that's showing hemibrain cell type matches in FlyWire.
The world feels
sorry, I think it's playing a Kurzgesagt video in the background. I shouldn't be trusted to host Zooms, apparently. So you can, we'll include, go ahead, Greg.
No, I was just saying I can sit and watch that a long time. But anyway, yes, it's a lot of match neurons.
So many beautiful neurons.
I guess you can probably, if you look closely, you can see that some of them are truncated, the hemibrain ones. So they're normally on the left of screen, and there's a story.
All right. Well, it's about 11:03, so I am going to hop into a quick Codex and FlyWire demo. So I guess, first of all, let me just say hi. I'm Amy Sterling. I'm the crowdsourcing manager for FlyWire, and I've been working with Sung Lab for the past 10 years, actually, on citizen science with Marissa Sorek. And I guess in the past 2 years, we've moved over to FlyWire, working on the user interface and also on Codex. So there's a team of engineers and I who are working on making this Connectome Data Explorer easy to use. And we would welcome your feedback. So as you look through these demos and as you start to use these software tools, please think about how we can make them better, what features you would like to see, what modifications you would like to see. And I also just want to say thank you so much for the interest. It's humbling and it's inspiring, and it's been so amazing to see everyone excited about this work that so many people have contributed to over many years. And if you guys have any questions at any point in this demo, feel free to hop in. We have the first author, Sven, here. We have the annotations, sort of lead Greg Jeffries here. So there's a lot of rockstar neuroscientists on this call. And also Philip Shu is going to be here, who did the fly brain simulation, if you have any questions for him. So without further ado, let me just hop into Codex. So we had a lot of questions about how to find partners of neurons, how to find your neurons of interest. So this is the Connectome Data Explorer. It's this GUI that lets you look at 127,000 neurons that have been proofread. 89,000 of those have some label. There's 32 million synapses. So this is with a connection threshold of 5 and 2.6 million connections among those cells. So does anyone have a favorite neuron that you would like me to search in here? Either put it in chat or shout it out.
L4.
Which one?
L4.
L4.
Laminar neuron.
All right. So we have 1,620 tags for L4. Any search result is going to default to this sort of view page, but if you want, you can also jump to stats. And this will give you sort of a high-level summary of all of your results. So if you have thousands of results, this can be kind of helpful. And actually, we have a lot of junk in here since we have all these extra input regions, but the stats view will show you a breakdown of all your primary input and output regions, neurotransmitter scores, class, all the other data that are available about the neurons. So if you wanted just L4, only neurons that only had this label, you can hit this little green plus and that'll filter it down to only the L4. So 144 neurons that have been tagged L4. And on the results page, you can immediately see the up and downstream partners. You can see a bunch of classification tags from Greg's group, and any community labels that have been added show up here. So if I just click on this is going to take me to the cell info page. So it's a kind of small neuron, doesn't have a lot of connections, but you can see this is the FlyWire root ID and has a 3D viewer of the neuron. It has you can quickly jump to up and downstream partners. Again, you can see the predicted neurotransmitters. You can see any labels and who has added them. And you can also directly add annotations within Codex. You do need to request the ability to make these edits. So if you find neurons, if you find that you would like to be annotating neurons in here, just drop us a note and we can schedule a Zoom to kind of just go through FlyWire principles for citation and editing. There's also a bunch of analysis tools down here. So you can find cells with lots of different connectivity patterns, similar input and output embeddings. You can run a reachability analysis, and you can even find matching driver lines. So you can choose your target library and hit submit, and then you will be emailed a link to driver lines, and you sign into Brain Circuits IO to find those. There's also some responsive charts at the bottom of every individual neuron page, and every neuron has this connectivity graph. So I'm just going to pop this open into a new tab here. So it defaults to 15 connections. This is a pretty small neuron, so I'm just going to go. I'm going to go and let's pick a big neuron.
Could I just, before you hop off L4, so
Sure.
I guess the optic lobe in general has not been densely typed as the central brain. I guess when Amy sort of clicked sort of to the right of the screen in order to select only things, things that only had the label L4, that actually reduced the number of neurons that were coming up quite substantially. So there's about 950 neurons that have been tagged as L4, but only about 150 of them have what's called the community label, uniquely tagging them as L4. So I guess there's kind of, it may be worth, you should get a lot more
Yeah,
hits.
I think it's because it's such a short name, and I filtered out all the noise by just clicking only L4, but there are additional, yeah, maybe this isn't the greatest example of neuron to plug in here, but play around with these sort of, if it's a short name, the search results are going to pull up anytime the letter combination is used.
So I guess maybe can one actually request just the things where the cell type is L4 and rather than the community label? I didn't quite see if that's possible.
we need the little plus mark next to cell.
So there's a function I think that you need.
Yeah, you can code that. So FAQs have information on that. So you can type cell _type equals.
Okay, cool.
And so there is equals.
Double equal.
Okay, equals, sorry.
And so this will only search cell type.
Yeah, so 951. Good. Yeah.
Okay. Greg's like, wait a second, there should be more than 144 of these. Okay, so I pulled up one of the larger neurons. So this big lobular neuron here, just so that I can show the network graph. So this neuron has 3,800 partners, 3,800 connections actually. And the network graph defaults to 15 nodes, but you can adjust this threshold slider. You can also change the way that you do grouping and, choose to show or hide brain regions. But if I just increase this number, you can quickly generate a connectivity graph for individual neurons, and they're filtered by neuropil. So you can see it's a lobula neuron, so it's receiving all of its input primarily from the lobula and output to the lobula as well. But all of these nodes are individual neurons that it connects to. They're color coded by neurotransmitter, and you can click this to jump to those other neurons. And in the network graph functionality within Codex, you can comma separate multiple neurons, so you can do a multi-cell network graph pretty easily within here. In Another tool that's probably going to be interesting for you all is the pathways tool. So you can choose a source and a target cell, or a set of source and a set of target cells, and it will generate a matrix of all the possible paths from A to B. So I'm just going to pull up an example one here. So this is showing all the possible routes from this taste peg gustatory receptor neuron to this neuron in the AVLP. And similar to the network graph, these nodes are the neurons color-coded by neurotransmitter. The edge weight is the strength of the connections, and you can click to open these in new tabs. So it's a nice way to find sort of network connectivity hubs. All right, let's see. In Codex, there's also a NeuroPill viewer. So these are all the NeuroPill from the FAFB data set, and you can click on them to add or remove them sort of in your visualization. So right now I've got the whole central complex, and so if you wanted to add the G&G, we've got all these in here. You can use this to easily find stats for neurons with either outputs or inputs within these regions. So let's look at stats for, neurons that have outputs in the central complex or the G&G. It's going to load, 12,000 neurons and just instantly jump us to the stats page. And this is all responsive. So if you, wanted to filter them by, primary output region, or, look at a specific subclass of neuron, if you click on those, it's going to filter your results down. So it's a nice way to get a high level glimpse at larger groups of neurons until you can get to some sort of list view to see, in greater detail, a smaller, more manageable group of neurons. Also from the list view, I forgot to mention, but you can jump to a 3D view sample. So if you have more than 100 neurons, I think it randomly shows 100 cells from your search results. But if you wanted to visualize all of them within FlyWire, you can download the cell IDs or copy the IDs. So this is just a random subset, 100 results of, the random neurons that I have clicked in there. They're also in Codex. Check out the FAQ, because that shows all the different searches that you can write within here. And once you've sort of made your way through Codex and gotten an idea of the connectome, and you want to kind of more programmatic driven workflow, check out the FlyWire apps page, because this has a list of all of the different resources. So Cave is going to be a Python package for analyzing connectome data. There's cat-made spaces. There is Coco Glancer, which lets you visualize FlyWire and hemibrain neurons from Greg's group. And then also CocoNat Fly, which is the R package version of NatVerse. And then also FAFBSeg Pi, another Python tool. But there's a bunch of apps that are listed on here that may be of interest. And then the last thing that I wanted to show before we hop into questions, because there were a fair number of questions, is I just wanted to show how the FlyWire editing platform can be useful as an interactive visualization tool. So this LPSP neuron is just a beautiful neuron in the fan-shaped body. So let me just open this up in FlyWire. Let me open it up in real FlyWire. So I'm going to hit spacebar to make this full screen. So this is the FlyWire editing and proofreading platform. This is where the almost 3 million edits were made to proofread all the neurons from the Fly connectome. And it's a pretty robust platform. If you're interested in doing proofreading, let us know. I think the brain is almost fully proofread, and we defined that as 95% of presynaptic partners of neurons that have at least 100 synapses being proofread. So right now there's a little bit of residual optic lobe, photoreceptors, but then that extra 5%. So there may be some sections of neurons that need small edits. If you find a small edit, feel free to email us, or if you'd like to contribute to proofreading, let us know and we can send you the self-guided training info. Okay, so this is the...
Can I just jump in quickly?
Yeah,
just
go
to
for
say
it.
That, you get a bounty if you find one in the central brain, because there should be, very little stuff left to find in the central brain. We've given that really a pretty good go over.
Yeah, you combed over them pretty well.
If you find something in there, you're I think doing quite well. But there will be stuff in the optic lobe still.
Yeah, it's still ongoing. Okay, so here's our neuron of interest. I'm gonna open these upstream and downstream partners. So here's the upstream partners. Just gonna copy these IDs and I'm gonna hide this neuron. We did it in green. So these are all the upstream partners of this neuron of interest. It's pouring down rain here in Boston, so we'll see how quickly my internet loads. So I'm going to use this plugin. It was actually built by one of the FlyWire users, Christoph Kruk. He has a bunch of plugins actually that can expedite and make your FlyWire better, like even just saving links directly within FlyWire. But this one we really like, which is just a GUI for recoloring your neurons. So I'm going to recolor all my visible neurons. We'll make these upstream ones purple. Change this. And then if I add back in our original neuron, it's taking a while for this segmentation to load, but you can start to see that it can be a nice way to see the upstream and downstream partners when you color code the neurons. And you can also do this, I think with Python, editing the JSON state directly within FlyWire. So it's loading a little slow, but we can also try the downstream partners as well. Turn all the seg IDs off. So this is your seg ID section. So each of the neurons in Codex have this long string of numbers, and that's the unique identifier for the 3D segmentation of those neurons. And you can paste those into FlyWire. All right, so these are the upstream partners. I'm going to recolor these guys. Let's make these maybe yellow, orange. And then I'm going to turn all these seg IDs back on. And we have our neuron of interest in green and the upstream partners in purple. I guess there's a little bit of overlap, and the downstream partners in orange. But you can kind of see this. I feel like it helps me kind of make sense of what's where when I have a nice visualization of the circuits and of the neurons that that I'm interested in. So FlyWire is a nice resource for building these visualizations. And if you're choosing, if I change the data set now, I think it's going to reset my view. But when you're in public release, don't share the link that's in your browser. Share the share link, hit the share button, and then you can copy this and anyone will be able to open it. So hopefully this will be a nice resource for collaboration and working together. And then the last thing that I wanted to show within FlyWire, I'm going to turn off the brain mesh, is that you can add annotation layers. So if I just click on this, if I just control click on this, it adds this new annotation, and you right click to open this layer, and then you can sort of select whatever 3D component you want to lead your annotation, and then you control click and it's going to leave. Well, I think I have too much segmentation, but normally control click. There we go. Got a little annotation right here, and you can make a note right here. And you can do multiple annotations. And when you share the link to FlyWire, it will share also your annotation layer. So it can be a nice way to point out things of interest, especially if you're interested in collaborating on something.
They are not global for annotations, by the way. They're personalized to your use case in that window. So just something to note is that it's a great way to leave your own personal notes for yourself or for sending to a colleague.
Mm-hmm. Let's see. Does anyone have any questions so far? Okay, well, I was going to try to keep this to about 30 minutes and I've already used up 20 minutes. So I'm going to stop our demo here because there were a few sort of submitted questions. So people were interested in finding neurons of interest, finding partners, workflows for programmatic access. And then we had a number of questions submitted about the whole brain simulation from Philip Shu, who's here, and about how to sort of get that running. So Philip, do you want to just talk a little bit about your simulation and how folks could kind of get one going for themselves?
Yeah. First, thanks for having me. Basically, the sad news, unfortunately, right now is that I'm on vacation and
Sorry.
we haven't published the GitHub repository, but we will do it next week. And so basically, after next week, you'll just be able to publicly download that GitHub repository. One thing that I will also mention is that FlyWire Slack can be a pretty useful source to look things up. And so I'll be available on the FlyWire Slack to help with that as well. But basically you would just download this GitHub repo, and we've got this example page and a set of example queries that you can do. And basically all the experiments, the computational experiments in the paper are on the GitHub repo that we will post in a week, hopefully. So I'm hopeful that it will be self-explanatory, but if not, you could just send me questions to the FlyWire Slack.
We will send out a follow-up email after this call, and we can include a whole bunch of links, including FlyWire Slack. There's hundreds of people in there, and it's definitely a great resource for getting questions answered about neuroscience or proofreading or software tools. Let's see, Sven, did you want to say anything about advanced workflows for connectome analysis?
I think Codex is a very good place to start. And if you want to do large scale analyses, you may want to do some programmatic analysis. And we have two main tools for that. The one is Cave, and that is basically a system that is running FlyWire in the background, and it has Python API that you can interface with. And the other one is NatVerse, and Greg is Coconut Fly, NatVerse under the hood. Okay,
yeah, it's sort of a wrapper for you know, using all the other analyses in NatVerse, but it's specifically targeted at FlyWire versus Hemi-brain analyses. That one, so comparative analyses. There's Philip Schlegel's FAF-BSeg NatVerse and my FAF-BSeg NatVerse, just for generic FlyWire programmatic analysis.
And that is an R package, right?
Yeah.
Yeah. So basically you have these two doors that you can use for programmatic access, and then of course you can download the data and work with it locally. So I think these are the different ways for large scale analyses. There will be a proper Python tutorial coming out this week that will also walk through this in more fine detail and show you how to do it. Yeah, so I think these are the main things. I encourage you to also check out Brain Circuits.io. It has some other features, including the matching to the driver lines, if you want to match your neurons to existing Gal4 lines.
One other thing I wanted to share really quickly is this info and credits. So this at the bottom just has a citation chart. So depending on which data you use, here's reference for which papers to cite. And then there's a just sort of guidelines for credit and resources. And then there's also, you can download data on this page here. You must follow the guidelines for this data, but we did have a lot of questions about how to download it. So I'm just showing you all here. There's different tables that you can download, and it shows you exactly what's in each table. So just made it really easy on this download data page. Let's see, do we have any questions from any attendees?
Looks like we just got one, Amy, in the Q&A here.
Q&A.
About Gal4 line table.
Where a Gal4 line labels multiple neurons, can we use that information to search for neurons?
That is a good question. I haven't done it myself, but I believe that should be possible through Brain Circuits.io, that you get all the hits from one Gal4 line, but you will get probably many of them. I can follow up with Stefan. So Stefan Gerhardt is the one in charge for Brain Circuits.io, and he, under the hood, is using the color map system that has been published, I believe, 2 years ago, for making matches. And yeah, so these will be many. I will follow up on that.
Yeah, I mean, just to add, basically that's an interface to the neuron bridge search from Janelia, FlyLight, and FlyEM. So the neuron bridge search currently includes hemibrain neurons directly. So they're kind of within the corpus of data, but it doesn't include FlyWire neurons directly, right? You can upload them and search. So my perspective on that is that I don't think it would be possible to search in the other direction. So if you had a GAL4 line, your best bet would be to use MCFO, multicolor flip out data, for that GAL4 line if it existed within the Janelia corpus. But then I don't think there's a way presently to search all FlyWire neurons against those multicolor flip out data. So yeah, I think you would currently have trouble doing exactly that query.
We have a question from Jan Lapalainen. I'm sorry that I probably said your name really not well.
No worries. Hi, I'm Janne. Thanks for this presentation. I think this is really exciting. So I have one specific question, maybe 2 or 3 high-level questions. Maybe, do you have number on the coverage, numbers on the coverage of the optic lobe? So Greg, you already mentioned that the optic lobe is more sparsely annotated than the cerebral.
Yeah,
maybe
so
numbers would be very
I
interesting.
mean, I could add a few things, and Sven can and probably others can say. So for the so the whole brain, right, is about 130,000 neurons. You can like super roughly divide it 1/3, 1/3, 1/3 between the left optic lobe, the central brain, and the right optic lobe in terms of numbers of neurons. So Sven kind of declared a semi-official victory for the optic lobe in late March, based on one criterion. But there has been proofreading subsequent to that, which will certainly be reported in a revised version. In terms of the actual annotation, I guess the systematic annotation, which is basically trying to provide kind of the same structured information for all of the neurons in the same way, which is what our group has been doing, has focused on the central brain because that's where most of the cell types are, even though the majority of the neurons are in the optic lobe. I guess in terms of the amount of stuff that has an annotation in the optic lobe, other than a pretty broad one, like whether it's an intrinsic neuron at the optic lobe, a visual projection neuron, or a centrifugal neuron, it's probably still only around 1/3 of the neurons in the optic lobe. And we know that there are many rarer cell types or more complex cell types that don't have any information yet. Also, for the central brain, I would say that the biggest chunk of annotations have come from our group in those structured annotations. But for the optic lobe, there's been a significant effort from actually some of the citizen scientists who've contributed some of the typing for the columnar neurons. So I've just to take a look, I've reviewed some of those, and in general, they look pretty good. But just like the proofreading, they kind of haven't had sort of a second pass in some sense. So I think you can, whatever you find for community annotations for the optic lobe, I think there's lots of good ones there, but they haven't yet all had some kind of review by a second party.
Yeah, there is a big effort underway, and actually I just put a link in chat to this optic lobe sort of tagging dashboard, which we've been using internally for organizing our optic lobe tagging. So it'll just give you a snapshot of what percentage of at least the columnar types we think have been tagged on both on the left and right side.
Okay, cool. Thank you. That's great. Maybe more high level. So I've been working on the optic lobe a lot, and I think the data on the cell type function is very heterogeneous also. And I was always thinking it would also be great to have a centralized database. And are you planning for like extension point for cell type function, or maybe with Philip to extend it to connectome simulation within your software? I think it's a really great software that we develop.
I don't know an answer to that. Go Sven.
But you were referring to Codex, basically.
Okay, Codex has. Okay.
No, sorry. You were as of were you referring to Codex or more general?
Just more general, like your web application. I can click through and look at cell types, right? But then there are cell types in the optic globe which are responding to light increments, others to light decrements, and I would always find this great to explore what is known and what is not known, right?
Yeah.
And I think that could be very valuable also for the community. But I know that this is data which is distributed across many labs and very heterogeneous, different recording methods. Just wanted to ask if this could be extended, basically, and I believe the answer is yes. But maybe I'd let you.
I think the answer is yes. It is in the end comes down to annotations of neurons that need to be ingested and collected, and the most work is usually in the curation side to make sure everybody calls the same thing, so that it can properly be searched. But yeah, in theory that's possible. It just needs always an effort by some small group to make it happen for one specific annotation. And yeah.
Could I just jump in quickly there, because there is there's not just sort of community effort there. So there's also a resource called Virtual FlyBrain, which has been running for over 10 years now, which curates the published literature on fly neuroanatomy and fly neuroscience in general. One of the things that they do is whenever somebody describes a new cell type, they will produce a structured definition of that cell type and also a permanent identifier for that cell type. So many of the annotations, so all of our annotations, where possible, will have one of these identifiers. And actually many of the community annotations for the optic lobe have also included these identifiers, which are called FBBT identifiers. So if you see a number FBB T underscore something or other, you can take that and put it into Virtual FlyBrain. And on Virtual FlyBrain, you'll get a whole load of information about that cell type, including papers that have worked on that cell type, links to molecular resources that have been published, how that cell type fits into sort of, the hierarchy of, it's actually a DAG of cell type terms. So that's currently, I would say, the best sort of single location to get functional anatomical information for any given cell type.
Thank you.
It would be really nice to have a simulation running with the visualization. You could turn cells on and off and
I guess Aurel Lazar and Go at in New York have been working on such simulations for a while, and they have in the past ingested some of the previous light level and connectome data sets and tried to make something computable there. I don't know if you played with that, Philip.
Actually, maybe one more question regarding that. I think so far we've been simulating point neurons. I was just wondering, as a feature, it might be nice to be able to export a graph of point neurons with like the center of mass of each cell or something like that. To be able to have the connectivity graph like with clicks of selected cell types.
If you go and fetch those CSVs, you can make one yourself if you want to.
Yes.
Not too much hacking. You can get the synapse locations and the summarized edge connectivity.
We also have a representative point for every neuron that you can use. You don't have to compute that one yourself. But that's a good segue, I think, to the other question that we have in the Q&A section. The question about synapse level information and distances between, in general, distances. So the the synapses themselves are available. There is a reason for caution. There are a lot, so you will get a lot of data at once. And if you want to load it all, that might be too much to hold in memory. But there is this information, and you can pare it down to neurons of your interest. Every synapse comes with a neurotransmitter annotation prediction. We aggregate them by taking an average across all the outgoing synapses to produce what you see in Codex. But yeah, they're available per synapse, and we know that some neurons have do co-releases, and currently we don't. We did not use any of that information. We just averaged across all outgoing synapses. But once you have the synapses, you can also download the skeletons that are available. And by combining synapses and skeletons, that would allow you to compute distances between synapses along a neuron, for instance. That's how you can get distances, but synapses also have spatial locations you can directly compute, also Euclidean distances between them. And every synapse comes with annotation of pre and post synaptic, so you can group them by pre and post synaptic partners.
Just to say for that last thing that Sven was mentioning, so in that first FAT-BSEG package, there's a particular function to attach synapses to a skeleton, and then also examples of how you can use that to compute geodesic distance across the reconstructed skeleton between synapses. That's something you want to do. I'll stick a link in the chat.
And while we're talking about representations, so skeletons are a great representation to compute distances because they're sparse representation. If you want to have a more rich representation of a neuron, the meshes are available for download, so you can also download those. In the end, they are basically also a graph of edges and points. So that would be another means another representation that you can use if you wanted to. And they can also be downloaded to make your own visualizations, of course. And we also have packages for that.
We had one other question about pasting more than 10 neurons in the source and target and pathways tab. Yeah, I think it is capped at 10. The matrix only fetches pathways for the first 10. I don't know how you can see the full list of the neurons, actually, the pathways of a larger list of neurons. I can look into that and try to get back with you, Abhijit. Let's see, are there any other questions? All right, well, I guess we can conclude our FlyWire and Codex demo. Thanks everyone for coming in, and thanks for all the enthusiasm. It was a crazy weekend on Twitter. Sven's original preprint launch thread got over 3 million views. It's crazy. So glad to see this research getting some enthusiasm from the community, and we hope that it proves fruitful for you. And again, let us know if you have feature requests or feedback, things you'd like to see, especially in Codex. We're flywire@princeton.edu. And thank you so much for using the software in this Connectome. And please add annotations to it. All right, I'll stop our recording.